Hi everyone, in this video we're going to look at the first part in chapter 4 of IP services. So the first part is time synchronization. A device system time is used to measure periods of idle state or computation. So therefore it is important that time is consistent on a system because applications often use the system time to tune internal processes. Here are some key features of why we need to maintain or synchronize the system time. First, we use it to manage passwords that need to change at specific time intervals. Next is we want to manage the encryption key exchanges. And this is very important to keep the time synchronization. Next, we need to check validity of certificates based on a particular expiration date and time. Next, in terms of managing security-based events, for example, routers, switches, firewalls, network access control systems. So they need to have time synchronized because we need to correlate these events between the devices. Finally, when we need to correlate these events, it's usually because there are some errors and we need to troubleshoot these errors. So when we need to troubleshoot, we need to get the information that is synchronized from all the other devices. So one protocol for time synchronization is called NTP or Network Time Protocol. So this protocol is used to synchronize a set of network clocks in a distributed client-server architecture. NTP uses UDP-based communication and they communicate in port number 123. So in a client-server architecture, there is a hierarchy for the NTP, and the highest hierarchy is the authoritative devices. They operate as an NTP server having an atomic clock. An atomic clock is the most precise type of clock in the world. So how it measures time is by measuring the natural vibrations of atoms. So for example, atoms, they naturally vibrate at an exact time per second. So when you measure, that means the measurement is very precise. So at the top is the server, and then hierarchically, you go down the tree, you have the NTP client who queries the NTP server for the time that has been measured using the atomic clock. So the NTP client gets the time from the NTP server and then updates its own time based on the response from the server. So actually the NTP synchronization process takes time because it requires hours or days of comparison between the NTP devices. So since it takes a lot of time when they want to synchronize between the devices, there needs to be a measurement of this delay. So this is called a stratum. So stratum is used to identify the accuracy of the time clock source. So for comparison, the NTP servers which are directly attached to an authoritative time source, they have stratum 1 and they are considered stratum 1 servers. So subsequently, an NTP client that queries a stratum 1 server is considered a stratum 2 client. So the higher the stratum, the greater the chance of deviation or delay in time from the authoritative time source due to the number of time drifts between the NTP stratum. So let's look at the basic configuration of NTP. Here we have a very simple topology of router 1 and our router 2. Router 1 is the NTP server and router 2 is the NTP client. They communicate via the gigabit Ethernet interface in the 192.168.1.0/30 address range. So let's configure R1 as the NTP server. So the simple command is NTP server and the stratum number. So here there are only 2 devices. So the NTP server has a stratum number of 1. And let's configure the time zone. Time zone, Malaysia. given Malaysia, and then the hours difference. So system clock has been updated to synchronize with the Malaysian time, which is for today, May 19, 2025. So over at the router 2 to become the client, so we configure NTP server and the IP address of the NTP server, and we can add the keyword prefer as if we have more than one NTP server, so the R1 will be the preferred NTP master. And then we can also additionally uh, add an update source. So for example, if router 2 is communicating with R1 using the NTP protocol, its source IP address will always be the loopback 0. So reason we configure the source as a loopback 0 is because loopback is always active. Let's verify our configuration. So we use the show NTP status command. So now we can verify that indeed router 2 is referring to the NTP server with the IP address 192.168.1.1. So now the stratum of router 2 becomes 2. Since we put R1 as stratum 1, so the downstream router will become the stratum number 2. So we can also look at the frequency at which they synchronize with each other. So the server has been up, the NTP server has been up for 406 seconds. So the reference time is 10 a.m. And Monday, May 19, 2025. So we also have the offset. So like I said, there is some delay because of the synchronization, but it's only in the range of milliseconds. So in the background, the two routers will communicate in the NTP protocol. So you can see that the last update was around 74 seconds ago. So it will continually be running in the background to synchronize the time with the NTP server. You can also run the show NTP associations to verify whether the correct server is the one that we've configured. So we have now the address of the router 192.168.1.1. So the reference clock for the NTP server is a local clock. For example, if you have the NTP server router 1 synchronize its time to an atomic clock, it will say so here lah, at the reference clock. But for now, in our case, just now we just created the time zone, or we set the time zone in router 1. So basically it's a local clock that is used as the synchronization clock. So you can see here the symbol on the left, okay, where you have the asterisk is the system peer. So it's on one level of peer. Later we'll see the term peer for NTP. And next to it is the tilde sign, which means it is configured. That means we manually configure the NTP server of 192.168.1.1. An NTP client configured with multiple NTP servers will only use the NTP server with the lowest stratum. So that's the importance of when we configure, what stratum number do we configure for the NTP server. So here we have one simple topology where we have the atomic clock, and router 1 is directly referring to the atomic clock in and becoming the NTP server. Router 2 is in stratum 2 because it's downstream from router 1 and is referring to router 1. Router 3 on the other hand is referring to router 2, so it's becoming stratum 3. However, for router 4, it has two NTP servers. So now, when we have two NTP servers, it will refer first to the server with the lowest stratum, in this case, router 1. So the current configuration is the time synchronization is done with router 1's clock, which is directly referring to the atomic clock. However, when something happens to the network, for example, router 2 crashes, okay, so the downstream routers will have problem of synchronizing the time. So one, because you cannot directly access router 1 for the stratum 1 reference clock. So since it is connected or associated to multiple NTP servers, now it will look at the nearest NTP server with the lowest stratum. So between stratum 1 and stratum 3, and now stratum 1 is becoming unavailable, the next reference clock will be stratum 3. So now the stratum level of router 4 has changed. Previously, since it was directly referring to router 1 as the NTP server, so its stratum is the downstream number becoming number 2. But now since it's no longer referring to router 1 and is referring to router 3, and the stratum number of router 3 is 3, so it will be stratum 4. Here we look at the difference between a client and a server and a peer. Alright, so when there is an NTP server and it has a client, so the NTP client synchronizes its local clock to that of the NTP server. But the NTP server will never synchronize its own clock to an NTP client. The only type of NTP device that can synchronize with each other is if they are both NTP peers. So you can use the command NTP peer and the IP address of the next device that you are peering to. So in this case, the simple topology of R1 and R2 becoming NTP peers means they can query and also synchronize their time to each other.